Hello everyone. Good morning. So this is our fourth class, right? Fifth class actually. Okay. So in today's class, right, we're going to deep dive into some of the Cairo types construct, right? And what we're going to look at are some of like the capstone of like types that you want to use every day when you're writing your Cairo programs, right? And these features will lead us into what you actually be doing, right? When you're writing your Cairo smart contract. But it's important that we know this construct, right? Because when you're writing your Cairo programs, right, you will dive into that part, right? You will use them a lot when you're either writing your Cairo programs or you're writing your Stacknet smart contract. And what we'll cover four key areas, right? We'll cover enums, we'll cover arrays, we'll cover dictionaries, and we'll also cover error handlings, right? We'll also cover error handlings and using match with enums to see how we can catch errors when we have. Okay. So before we start, right, can you guys give me a like sort of what you understand by so yeah, so can you guys give me like what you understand by like when somebody said he's writing like a Cairo program, what comes to your mind? Anybody? Okay, somebody is speaking on the call. Okay, so essentially, right, when you're writing Cairo programs, you're writing programs that can be proven, right? So when you say 1 + 1 is 2, when you run that program and you give it to somebody run that program, is going to get 1 + 1 is going to get 2, right? So essentially, you're writing programs that are soundproof, right? And once it gets executed, you can't come back and change them, right? Now, what we are going to look at in this section is arrays, enums, and dictionaries. And we're going to start with enums, right? Now, when you hear enums, right, what comes to your mind? Okay. Yeah, collection of similar data, right? So enums are, from the name, right, enums, they are basically enumerations, data that you want to enumerate over them, right? Let's say, for instance, your grade, right? I mean, our grade doesn't change, right? You're either getting if a good, very good, fail, excellent, right, or pass, right? Like those data are there, right? They don't change, except you want to add another one, right? Now, those kind of data are what you put in an enums, right? Data that you know that they are constant, they don't change, but you need them for specific use cases. For example, the grade we have, right? When you're writing a program that sort of like score student grade, right? You know that there's a range, right? When you get a 45 and above, 45 and 60, you know that you are in a pass grade, right? 45 to 55, you're in a pass grade, right? So automatically, when the system runs and you find out your score is that, automatically pick that enum and assign to you, right? And when you have that for 70 and above, automatically know that this is an excellent grade and automatically give you that excellent grade, right? Now, from the text here, right, we said that what? Enums, short for enumerations, right, are ways to define custom data type that consist of fixed set of name values called variants. Now, when you define your enum and you call them grade, those variants that you keep inside, those values that you put inside, they're not exactly values, right? Those constant data that you put inside are called variants. So your pass, your fail, you're very good, you're excellent. Those are the variants, right? They don't change, right? And it's the same thing with the example we give here, where we say we have task status, right? We have pending, in progress, completed. So now when you're given a work to do, right, when that task is created, it has what, a variant of what, pending, right? Because nobody has been assigned to it, right? When they give you that task, automatically that status goes back to what, in progress, right? And then once you are done with it and you submit, for example, a PR, somebody is going to review it and it get merged, that particular task will be marked what, completed, right? And everybody that is given a task will have to go through that particular stage. Now that's like a use case, another use case of using enum, right? Now, enums are useful for representing collection of related values where each value is distinct and has specific meaning, right? Like the example we give, right? When the task is created, it has what, pending, because nobody has been assigned to it, right? When you're assigned to that task, it automatically means that you set up, like, there's a progress in the task because somebody has picked it up to work on it, right? And once you submit it and it has been reviewed and accepted, it marks as complete, right? Now, that's like a way to sort of like define this. We're going to look at it in the code, right? But I want us to look at like the different sort of like ways to do that, right? Now, another ways to sort of like define enums with variant is you can also define enums with variant that has associated values. Let's take, for instance, in the same grade, right? You have your program that sort of like calculates student grades, and when you pass in the grade, you want to call another function that basically accepts the grade and the value. Now you can define your enums to have your grades and attached associated value. Those associated values are basically like the score that student has, right? Like in this case here, we have our enum of directions, right? We have north, east, south, and west. And they all accept a value of U125, which means when you define them, you will need to pass in the value that they accept. Yeah? And that value is what we term as associated value, because the value associated with a specific variant inside the enum. Now, I know it's a bit theoretical, so let's look at it in code and see how that turns out. Okay, just give me a second. Now, we need to clean up all of this. I know you guys have done a basic structure of Cairo program, right? Every Cairo program has to have the main function, right? Where if you sort of like write your code somewhere else, you need to import them into your main function. That's like the entry point in your Cairo program. Every Cairo program must have that main function. And that serves as the entry point in your Cairo program. So if you take the main function as in your Node.js program, right? You always have index.js, right? Either index.js or server.js, who serve as your entry point. Exactly, the same thing with this one. Your main function serves as your entry point into your program. And depending on what you want to do with the entry point, right? Some people do say that, okay, my entry point will return a value. Some entry points, some main function don't return anything. As we're going to see in this case, we don't want to return anything in this case. So we'll need to remove them. Now, to define your enums, right? What do you do? Aha. So you can see now this component that we've not like used it, right? So when you think of it, right, when you're writing your program that sort of like calculates grade of student, right, you want to either define a constant that define all of them, outside of your program and then you import them into your program and use to execute, right? Or you sort of like write them in a separate program and then import them into your program as we did here, right? So we define them outside. So it's always important that we define them outside of your main program, and then when you come into your program, then when you come into your function, right, and then you sort of like call them directly, as we've done here. Now, so but we get the hang of the idea of what you can do with enums, right? Yeah? Okay. Now, apart from that, right, enums also have like a sort of like, you can define enums and sort of like have the way for them to sort of like hold generic data types. Now, apart from user-defined enums, where you define your enums and all of that, Cairo program, the library Cairo programs, the Cairo core library, right, comes with two enums, right, inbuilt enums, right, and one of them is the result enum and the option enum. Now, both of them are very like important in your programs, right, and they have specific use case, right. Now, the option enum, right, is basically a way for you to represent, let's say you have a program that either like do some calculations that either return you a value or return you a null value, right? But you're not exactly sure what it returns for you, right? But you know that when you give it a value, it does the calculations, either return you a particular value or return you a null, right? Now, that's where you want to bring in your option enum. And it has it defines, it has two options, right? Sum and none. Sum basically contains the value that is being returned, right? And none basically contains nothing. So for instance, you have a program that does a division, and you want, every time there's a division that, let's say you pass in a value that is indivisible, right? You want to return option none, right? But if that value is divisible and you have a value, you want to return it as a sum, right? Now, the text here, what does the text here say? Option enum in Cairo is a way to represent value that might be present, some variant, right, or absent, none. It helps avoid null pointer error by explicitly handling cases where value may or may not exist. Now, how do you handle that? And that's where another language construct called match comes into play, right? Now we're going to sort of like write this program in code. Then we'll see how the option enum is being used and how your calling function can use it to catch either the sum value or the null value. Now, I'm going to go ahead and do some, first of all, let's say we have a function that gets user, and what does it do? It's basically accept an ID and say of U32, and what does it do? It returns us an option. Yeah? To 52, right? Now, I'm very sure you'll be wondering, you said we have option enum, right? And that option enum returns, it has two variants, right? So why are we having option enum of 252 here? Exactly. So when you define a function and that function is expecting to either receive a value or a non-value, in your function definition, you want to define what you want to receive in the option enum, right? So in this case, we want to receive an option of FL 252. You want to define the sum value. You want to define the present value. Yep. What's going to be present? And in this case, it's FL 252. And remember, this is something called generic type, right? Okay, yeah, exactly. So enum hold generic data type in their variant, right? A generic type is a type that is parameterized, right? Meaning that it can work with multiple concrete types without being explicitly defining it for each type. Now, what we just did here, right? What we just did here was to say we define what we wanted to return. I can decide to make you return a U252 value.
Apply this class,
yeah. Somebody asking a question in the call? Okay. So, it's returning what? FL252. Now, you want to define the present value, not the absent value, right? Except in your program, you explicitly want to get the non-value. If you want to get the non-value, then you want to define none. And every time somebody calls this function, it's going to get a none, depending on how you sort of like implement the code in the program. Now, in this case here, what we are saying here, every time that the user, the ID is of, let's say here, 5, right? What do we want to do? Can you see? Can you see? Can you see? Option none, right? Or what do you want to do? You don't want to return, just option none. Oh? Yeah, but I don't think that's like, that's exactly it. Yeah. Yep. Yeah. And that's because the program already, now here, we're returning FL252, and FL252 always return a single code. Now, every time somebody calls this our program, right? When we execute this our program, let's say we say user, right? And we say get user, and we'll pass it 1. Now, because it's returning an option, we need to check, we need to run a match, and that match basically pull 2 things for us. Either it return the option value, the sum value, or the non-value, right? Yeah.
Can we access an enum by index instead of like by the variable? For instance, can we do options with these 2 dots maybe at index 0? Is it allowed in Cairo?
No. So that's why we have the variant, right? That's why we have the variant, right? So when you're defining your enum, you define your exhaustive list of variants. And when you want to get access to them, you have to point to that variant that you want, right? Yeah, not the index. So if you want to use index, then you have to use a different construct, which is array, which we'll get to that after this. Now, for us to, what this returns is option enum. Can you see? Can you see what he's saying? It returns what option enum of 252, the sum value. But because we don't know what this function returns for us. Now, this is because I'm the one that write the program, right? This particular function, I know what it returns, right? But if it is someone that picked up that this is my library, I want to use it in his code, and from the function definition, because he's going to see the interface of how I define the function, right? But he's not going to see the implementation. But he's going to see the interface, the function definition, right? He will get to see this, right? And by mere seeing this, you know that he's going to return an option NO. And how does he handle that? He needs to use the match construct to check for either the sum value or the non-value. And just as it's done here, yep, user, yep, then we say option, yep, sum. So again, you can decide to give it whatever name you want to give. If it is a score that is expecting, you can say score. But if it is a name is expecting, so you can decide to use name here. But in this case, we're going to use words here. Yeah? Now, you define what you want to do with it. So if you get a present value, what do you want to do with it? This is where you define what you want to do with it. Do you want to call another function that does something different? You call the function here. Do you want to print it out? You print it out here. Whatever you want to do with it, you do it here. But in this case, you want to print it out. Yeah? Yeah? Then what? We put in the word. You notice that, yeah. Okay. Why? Okay, I'm wondering why is it shouting? Print statement, name line, macro syntax format. To print to the standard output with new line. This macro is used to syntax as format, but written in standard. Okay. Let's complete. Then option, right? Now you want to catch the none. And when you get none, you notice that our none does not receive any value, does not receive any. Can you get? It doesn't receive anything. Yeah? So you can decide to create your own enum that sort of like say, okay, each value receive a particular value, like we have in direction. And then in your match statement, you match and then you get that value out and then use it in your program. Now, here we can start to say, okay, yeah? Oops, sorry. Okay. Yep. Yep. You can decide to say word not found. Yeah. Oops. Now, if let's run this program and see what we get. And just on the context, right? I'm passing a 1 here. So what do we expect? Let's see. Exactly, yeah? That's because our program is expecting what? If you pass me a 5, right, I want to return you a present value, in this case, which is the sum, right? But if what you pass is not 1, then you pass in this. Now let's take an instance, I pass in 5. Yeah. Let's see what we get. Exactly. So it's assigning us the value, right? So we need to disrupt. It's assigning us the hash value of what we pass in here. File 252 of this value. So we need to, there's a way you can do into to get actual value from there. Now, that's like one of the enum values, right? In one of the core enum from the core library, right? Now, the second one is the results. Now, the result, right, is basically in a case whereby you want a program to run and either return a particular value or return an error. And if you notice the difference between the result and option enum is the result accept T, which is the present value, and an error. Okay. And you could see. Okay, I made a mistake. It's supposed to be Rust. Okay, I mean, obviously, this syntax is something that is sort of like synonymous to what we have in Rust, right? Now, the OK variant, right, is what holds the success value of T. And then the error holds the error value of E. Now, let's say, for instance, you're writing a program that, in that your Cairo program, you need to make a call to an external service to fetch some data. Or let's say you want to get a current value of some assets. Let's say you're working on a project that has to do with real-world assets. And you need to, you have a Cairo program and you need to make a call to a particular service as to get a particular value in. Now, because you don't have control over what that particular service sent back to you, a perfect way to handle this is to use the result enum, right? You either get a successful value or you get an error. Now, in your program, you want to destructure that. Now, whoever is writing that particular, whoever has that service will return you a particular value, right? It's either you return you a result or an error. So it's left for you to now handle that case. And the way to handle it is to use what your result enum, right? And again, the same use case, right? You use the match operations on result enum to either handle the success or the error. And like we see in this example here, right? We have what a result division enum, right? This is, now, another very good part of it is you can actually like define your own specific results enum, not just stick to what we have, what you're given in your Cairo program, like in your Cairo library. Like what we have here, right? We define them and says, okay, this division result will always return two values for us, okay of U64 type or error of 252. And if you notice that in the result from core library, it does give us two variants, yeah? Two generic type, T and E, right? So it's left for you to define what that T will look like. And if you look at it from this result here, what do we have? We have a safe divide that returns that accepts U64 of A and B, right? And it returns us an enum value, right? Now, if the result is 0, right? What do you want to get? It returns back that division is by 0, right? It returns us an error enum, right? And if it is else, right? If it is an OK division, it returns over an OK value. And like I said, right, you need to use what? Match. Match is like one of the options that you can actually use to sort of like the structure like enum values returned from a particular function. If a function returns you an enum, an option or result enum value, you can use either match to do. Now, match is like sort of like the preferred way because you define all the two cases and you define what you want to do with them. If you don't want to do anything with them after you return them, then you can basically use unwrap. Unwrap basically says, okay, if it is not a result or a sum value, panic, right? But if you know that you want to, if you get a result value, you want to do something with it, then you use your match. If you get an error value and you want to do something with it, you use your match. Sum, whenever you get, you either call on that function or do whatever you want to do with it. If it is error, if it is a non-value, whatever you want to do with it, okay. If it is a non-value, whatever you want to do with it, you can decide to do what you want to do. But if you know that you just want to get the value, you don't care what it does, use your unwrap. Once it is not a sum value, it will throw an error, it will panic, and the program will stop executing, right? But when you get a result, it will do something, it will give you that result. And coming back to this example, right, we have two results, right? We have the result of safe division of 10 and 2, right? And then we have safe division of 5 and 0. Obviously, when you run this program, because we are the one that that wrote this program, we know that if it is divisible by, if what you pass in as second argument is 0, right? You're going to get cannot divide by 0, right? Which is exactly what's happening here. Now, let's copy this code, right? And sort of like play around with it in our code editor. Now, going to now, like I said, this is like another example, right, of using result enum, right?
Yes, sir.
Now, let's see, we have yeah, save division, and let's say we pass in 8 and 0. We can do match results, yeah? And what do we want to do? You want to do option, yeah. And in this case, because we define a custom enum, right, that mimic the result enum, right, you want to match against that. Yeah, and in this case, you want to say that, okay, there's a value being returned. Yeah, and in this case, you want to see, I want to print out what we have. Oops, sorry. Okay. Yeah. Value, right? Yeah, so default division, right? The error, right? And also the value, yeah? So who can like sort of like give me like when you understand, like when you notice the difference between option enum and result enum? I didn't get that. Can you speak up?
Is always the value in the result enum. Like, it's
Yeah, it's almost close. So the difference is that in option enum, right, you have some which accept a value, and then none doesn't accept any value. But with result enum, you accept two values, the actual value and an error. So in this case here, we see, that's why we have it here. And I mean, it's option, right? Some and none. Result has what? Okay and error. And you define where you want to pass in for those two values. Yeah. Error, result. Yeah. Yeah. Oops. Okay. Value. Oh. Okay. It's very like it's important that we sort of like do that. Yeah. It's bringing back an error for us, not a value. Yeah. Now, let's run this. What do you expect to get when we run this? Let's comment it out. Okay, that's it. It's in the error result. So what happens if you pass in, let's say, 2? So you can see that in result enum, you need to accept the two words, the two options, right? The results, actual value, and then an error, right? So just like I said, right, when you're a very good use case for it is when you're trying to use an external service. That external service, when you're writing like an external service, that's people passing value for you to do something for them. Let's say, for example, you have a real world asset that accepts the name of the asset and returns you a particular value. Now, let's say you as one working on that external service, you have your own logic that says, okay, every time somebody gives me the name of, let's say, coal, I want to return you the particular price of coal, the real world price of coal. Every time somebody passes me, let's say gold, return the real world value of gold. You define all of these values, right? You know that you are expecting certain name of real world asset, and somebody come and pass you particular animal name, let's say, for example, dog. Yes, it's a real world asset, but then there's no, you don't get that value in your own system. You want to return an error for that person. Now your function, when you're defining your function, you define using the result enum. Either returns you the error enum or returns you the actual value. So if somebody passing a name that doesn't exist in your own system, you want to return back an error, right? You use your result enum to return back the error. Now, the person consuming that your service will need to sort of like do a match to get the actual value. Now, you consuming that person's service, if you are very sure that you will never pass in a wrong reward asset, you always pass in an actual reward asset that extra service will handle. You can use unwrap. But the challenge with that is that the day you pass in a wrong reward asset to that function, that unwrap will panic. So if you use unwrap, you don't have to do much. You basically just, let's see, let's comment it out. Let's see how they. I want to sort of like go through this so we can move to array. We can say your actual RS. Yeah. Result dot custom result type. It doesn't come with the unwrap in its interface. But when you use the results and from the core library, it comes with the results. It comes with the unwrap. So that's on that catch, right? If you define your own custom results and you have to either implement the unwrap function or go back and use the actual result and so you get access to the unwrap. So depending on your use case, right, it's a bit tricky. It's very use the one of the best way to use unwrap is if you want your program to sort of like crash if a result is not being returned, then you can use unwrap. But if you know you want to handle the error, then you use the match to handle it. You have any question?
Can you implement like custom statistic for that option? Or like you said, so you can implement like custom result?
Yeah, so even with the option, you can define custom enum. Like, I mean, with this, right? Yeah, you can sort of like define a custom enum even here that says, okay, accept a particular value, but some accepts and then others don't get the value. I don't know if that makes sense.
Yeah.
Okay. So I mean, the wrap of enum is like enums have like variants that are sort of like constant in some ways, right? You define them to do certain constant actions for you, right? And then you can also use the core library, has two options enum for you that comes with the core library, right? Option enum and result enum. And like we said, right, when you want to use option enum, if you want to get a particular value or you want to get none, and you want to use result enum if you want to get either a value or an error. And it's mostly used if you have a function that you don't know what users will pass into that function. So you want to use result enum, right? Either you turn them an error or you turn them a some value. So yeah. Yeah.
You made mention about custom enums.
Yeah. So custom enums are like this, yeah, where you define them, right? And they can also have associated. They can also have like type that they accept. Like in this case, they accept what? U252. Each of them have U252, right? And you can sort of like define them to also like accept a T value. Let's say grade. And that grade, that grade can accept T. And you define all of your, what did you call them? You can define your goods and accept T, fail, right? It accepts also T and you can define your none and accept nothing. Now, when you're calling this function, you pass in the grade. Now, in your own case here, you define what this type will look like. The T is defined as a generic type. So when you're defining it, you will need to sort of like do what? Define what is going to accept. Let's say, for instance, here. let's see, for instance, here, my grade. Yeah, you can say, let's say now, yeah, and let's say 45. You get. But one good thing is when you're defining your custom enum, it's important, like it's good that you use define the type they want to accept. Now, what we did here, we used a generic type, so you can accept, if you're 252, you can accept a U2625 and all of that. But if you're defining your custom enum, define that has associated type, you define the type that it's going to accept. And if you see in this case here, U128, you can start to say, okay, everything here will be a U64. 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 Exactly. Hope is that clear? Hope that's clear.
Yes, sir.
Okay. Any other question before we move to Ari? Yeah? Okay.
So basically now, what is the difference between enums and structs?
Very, very good question. Now, in enums, right, they have variants. And those variants are like constant values. While in struct, they have what key value pairs. Get. You define a struct, you define the key and the pair. What is accept? You can define a struct that says, okay, accept if a key of L252 and a value of U68. Right? So when you're defining it, you pass in the key, which is FL252, and then the value, which is U64. So that's the difference. This one has a constant variant, and they don't change, right? While this one, when you define them, you define the keys and the value type that you accept. And then you can keep adding them. At the runtime, you can keep adding them. Notice that we didn't add anything here. When we define them, they're there. We didn't change them. At the runtime, we just call them. But with structs, when you define them, you can add values into them. So yeah, that's it. Now, let's come to Ari. Now, from your previous programming experience, what do you understand by the word Ari? Anybody? Hmm? Okay. Okay. So, I mean, arrays, right? See them as like a collection of items. Let's give, for instance, your work pack back, right? They are basically collections of all of your work tools, right? Your laptop, your charger, your extension box, your Wi-Fi, your router, all of that. If you look at it from a sense, they're all of the same sort of type, right? Because they basically aid in doing almost the same thing, right? Now, that's what sort of like arrays are. And if you look at it from the text here, we say that what arrays are collections of elements of the same type. Now, to create and manipulate array, we use the array tree from the core library. It's important to note that arrays have limited modification capabilities, right? The functions as queue, meaning their values cannot be directly modified once they have been assigned. Now, this limitation arises because memory slots, once written to, cannot be overwritten. Only read. Now, before we go into this, right, there's a very important concept in Cairo, which I'm very sure they've went through this with you guys, which is the memory, how Cairo handles memory, right? Okay. Okay, so this is something that you need to know, because when you start going deep, you start writing smart contracts in Stacknet and start going deep, you will start to see that how you sort of like write your programs in different languages is very different from how you sort of like approach this. Now, in Cairo, right, memories are immutable. That means once you write a particular memory slot, you cannot sort of like rewrite to that slot. Like you cannot go and sort of like rewrite to that slot again. When you want to write again, it's going to go into a new slot. So when you're writing your programs or your contract, you need to think in the way that, okay, this data that I'm accepting in my contract, do I want to change them over time? If I want to change it over time, then you need to think through. You need to like look at the type you're using for that storage slot, because of the way Cairo is. Now, this fundamental design, right, has several important purposes, like has several important reasons. One of them is security, right? Immutable memories help prevent various classes of errors and vulnerabilities which occur with mutable states. Now, yeah, because of the way sort of like Cairo programs are written, right? They're written sort of like as a proof program, right? As a program that can be proven, right? If I write a program that says this A plus, this, for example, this, oops, for example, this, right? If somebody picks this program, he wants sort of like validate what I've written, right? And you don't want to change the memory slot of it, right? Because that's already been written there. You can't change them. Because when you write a program, there's something that can be proven, right? So when you move out of them from here, you should be able to prove, right? Now, that's like one of the reasons, right? Now, and then like ensuring of one of the reasons again is ensuring of consistent outcome across all execution of the same program. Yeah. Yep. So when you write the program and you give somebody, when somebody go and execute it, you should be consistent. This is what it gets. If I compile the program, I give you the executable program, when you run it, you should be consistent with what I get. If I give this guy to, you should get consistent with what I get. You get. And then obviously, probability, right? Cairo is specifically designed to generate what? Zero knowledge proof, right? Of computation. And immutable memory simplifies that proving process. Now, it's important that we know this, because when you start to go deep into writing smart contract or writing Cairo programs, you come across this concept. It seems like at the core, at the very surface, you find that it's mutable, right? I cannot write and write. But there are certain logic that you write, you find that you're hitting errors everywhere. And why? Because you wrote a memory and you're trying to change that particular memory slot again. So that's where you start to get those errors. And by design, what we have with this, right? Once you append them, you get the value from there. Now let's look at this in code. How do I want to do? I want to. I want to be able to. Hope you are following, like from the theory example, like what we explained about arrays, right? Now I want to, let me see the back, yeah. Escape new. Yeah. Yeah. Cairo tests. I want to bring back this art folder to workstation. Okay. Second. Let's clean up this. Also clean up this. And I also want to clean up this. I want to have an now. To define a new array, we say did we miss any spelling errors? Okay, so who remember the almighty meet keyword? So for you to add, when you want to add a value to an array, it gets appended to the end of the array, right? In this case, we have array that was 0. There's nothing in the array, right? So we want to start. We want to use what the append keyword. So can you see, all of this are like the inbuilt functions that comes with the array. This array that we just defined, this array thread that comes from the core library, comes with all these functions that you can see them here. So append basically add an element to the end of the array, right? And let's say we want to add yeah. So I'm wondering why. Okay. Ambiguous method call more than one applicable thread with suitable self-type array append bytes. Consider adding type annotation. Aha. Aha. So that's why it's very important sort of like read what the errors is telling us. So now it's telling us that we are being ambiguous because we didn't define the type. Yeah? So we need to define the type that this new array is going to accept. And how do you define the type? By using this U128. Okay. Ambiguous call. Okay. So it's still shouting that we didn't. Ambiguous method call more than one applicable thread function with a suitable self-type was found. Array append and byte array thread append. Consider adding type annotation or explicitly referring implementation. Okay. Okay. Let's see. Some are right. And let's see, scab Cairo dash run, right? Let's see what this says. Did we do anything wrong when defining this? Let's copy exactly what we have here. Okay. So it's telling us that it can't find. Okay. So somehow my auto formatting imported this. So we don't need this. So why I'm having that error is because my auto formatting imported that string, and that's why it was shouting at me. But by default, the array trait comes with it. The call library comes with array trait by default. So when you install the Cairo language on your system, when you install the Cairo's executable on your machine, it comes with this. So you don't need to import it. But there are some use cases of language that you need to import it for you to be able to have access to them. Now, this is it. So if you run this, we should not get anything. Now, yeah? So to create an array, we use the array trait, right? Dot new, right? Then you want to append, right? We can pass expected type of item inside the array when instantiating the array like this, or especially defining the types of variants, right? Now you can decide to define it this way, and whatever the compiler will sort of like implies the type that you want to ask, that you're passing for the values, or you explicitly define the type. As we can see it down here, we explicitly define that this is going to accept a type of 120, U128, right? Unsigned integers are 128, right? And we have that. So when you create a new array, we use this. And then when you want to add element to an array, we use the append. Now if you notice in this case, we are not defining the keys, we're just appending. Because array has like an index kind of analogy, right? Whereby the first element has an index of 0, second has an index of 1. The positioning starts from 0, right? Now, if you want to update an array, now let's see what this content is saying, right? In Cairo, right? Memories are immutable, meaning once elements are added to an array, they cannot be modified. We can only append element to the end or remove element from the front of the array. Note this. If you want to add an element, when you do the append, it added to the end of the array. And when you want to remove from the front of the array. Now, this operation avoids direct mutation as they simply update the pointer rather than altering the memory cells. So you cannot carry out and update operations in an array. If you have, so that's why it's important that you sort of like know what you're putting in, right? And you can sort of like go work with that. And that's like we said, right? When you want to add an element to an array, you use the append method, right? When you want to remove element from an array, you use the pop. You can only remove element from the front of an array by using the pop-front method. This method returns an option. Now, this is where, even in the core libraries, right, there are cases whereby it returns you an option enum when you execute a particular function, and this is one of the options. When you remove an element, it returns what? An option enum, which contains the removed element or an option of none for array. Now let's see how this turns out. Because this is a very good use case of our option enum with the unwrap. Now, let's see. Oops. 24, 28, 32, 32, 22, right? Now, let's result. We want to remove the position, the element at position, the third position. Yeah? Pop font. Oops. Element at what position? Third position, right? So let's say third. Okay. Why is it shouting? Okay, so my keeps bringing this. I think my compiler has some. So you can actually see what is even, like it's trying to explain to you what that function is doing. Pop a value from the front of an array, return option of sum. If the array is empty, return option of none. Now, yep. Let's see what this is saying. Yeah. Oops. So I'm wondering why we're getting this. Yeah. So you don't need to, just like we said, right? You don't need to pass in the value that they are trying to remove. By default, it's going to remove the last element in the result. So that's why this is returning an error, because you don't need to. Yeah. So pop front remove the element. That's how the definition says here. Pop a value from the front of the array, like the end of the array, yeah? And then returns you an option of either sum or value. Now, we're going to get the results of this 22 because there's actually a value there. And then I'm going to show you a case whereby it returns an option of none. And you see how the program will panic because there isn't a unwrap. I don't need this. Why am I having this? Something must be wrong with my Cairo setup. Okay, so I think, so it's removing the first element in the array, and then when you're adding, it's adding it to the end of the array. Now let's clear up this. Now, The array is empty. We were trying to remove the first element array. So let's see what happened here. Yep. Yep. Panic with this option unwrap field. So you see what I'm saying, right? If you have a program that you want it, once it returns you a non-value, you want to panic. And you don't want to use the match case to check and all of that. Use unwrap. Once there's no some value in the option that is returned, it's going to panic for you. So yeah, this is it. Now how do you read element from an array? Let's look at what the text is saying. To access an element, you use the get or the at method that returns different types. Using the at method is equivalent to using the subscriptor operator, which is this. Yeah? Now the get method returns an option box, meaning that it provides an optional box, Cairo smart pointer, right? That hold a snapshot of the element at that specific index, if it exists. If the index is out of bound, it returns none. This method is particularly useful for cases for safely accessing element without risking panic when working with uncertain index values. Now, you want to use the get method to get value from an array if you know that you want to handle a case whereby you pass in an index and that index does not exist in the array, and you want to use match to sort of like match the value. Either it returns you a sum or a none, because this get method returns you two values. Either it returns you the present, the sum, or the none. And we can see from this example here. Yeah? So let's come back and do yeah, okay. So let's say we want to access index of 2. Now, you can, because the get returns you an option enum of either a sum value or a none, you want to get the value, right? You use the match to abstract the sum value or the non value. Now we can do this by saying R dot, now I'm executing the program on the match. You can decide to write the program, like write the function called separate, and then use whatever is being returned in your match. But in this case, I'm using it directly. Get, yeah, access index, right? Now, then always import this thing. I don't know why. Now, when you're doing your what did I call it? This challenge you guys are going through now. What did they call it? Stackling. You come across snapshots. But I mean, obviously, I know that you come across enums when you're doing that a lot. So, oops. Yeah. Again, can you see? I'm using X here. So you can use whatever keyword for the sum value. And what? Now, the get returns you like a snapshot of the value at that position. And for you to get the value of that position, what you want to do is do the snap it, and because it turns you like in a box. Oops. Okay, let's see what it's saying. Yeah, so let's just like this. Obviously, yeah. Yeah, okay. Now you can actually decide to actually print this. Print. Yeah. Yep. Now let's execute this and see what we get. So we are printing the results, but if there's not true value at that position, if there's not value at index 2, it's going to panic. It's going to panic and print this out for us, out of bound access. Okay. Okay. Yep. Can you see? So index 0, index 1, index 2. Exactly. So we popped up the first one, 20. So our index started at 0, start at 24, 1, 28, 2, 23. Exactly. So now let's comment out all of this. And then let's see how the program would look like. When it gets here, it's going to panic because it's trying to access value at 2 and it doesn't exist. We only had one value, and then we popped it out. So the array is empty. Now we try to access value at index, the value at index 2. And because the array is empty, it's going to return this none. And we are printing out what we're saying that it should what panic. Now that's the get statement. That's using the get keyword, right? Now the at, using the at. Now the at function along with the equivalent subscriptor operator directly retrieve the snapshots of the element at the given index using the onBox operator to extract the value from the box. Now, if the index is out of bound, it's going to trigger a panic. This method should only be used when you intend for the program to panic in case of invalid index. Now, if you don't want to handle the option of either if you don't want to handle the sum and the option using the match keyword, you can use the at. Now, once you access the index that does not exist, it's going to panic automatically. And we're going to see that here. Let's see. Yeah, let's see. Yeah? Let's see one. Let's see one. Now, I'm going to do one dot. And then I'm going to try and get I want to get the value at 1, obviously. Yeah? want to print it out. Okay, let's see what this does for us. Yeah. Yeah. Let's see what this does for us. Can you see? So, if you look at it very well, I think it would be better I commented this first one so we can see exactly what we are doing, right? Yeah? So, let's do it again. Exactly. Now, we created a new array, and then we added 12 at index 0, but we tried to access at index 1. Now, using the at, if the position you're trying to get access to does not exist, it's going to panic automatically. So, and if you notice that we didn't even use the unwrap, sorry, we didn't use the match keyword, basically just printed the value, the actual value from the box, right? Using the secretary operator here, using the snapshot, right? And it's panic because we're trying to access value at index 1, but the array only has one value at index 0. Now, if I come back here, and say, let's say 14, yeah? I'm going to execute. Exactly. So it won't panic. So the key difference between the two, the get and the at is, the get returns you a none, a some value or a none. So you have to use the match keyword to unwrap it. Or you use the unwrap. So okay, if you didn't get, if the sum, just panic. But the at, if you try, it returns you a value or it panic automatically. If the index you're trying to access does not exist in the array, it's going to panic automatically, as we've seen from the example we gave here. So like these are like the two key differences between the two of them. So depending on what you want to use, right? If you want to panic every time somebody access a index in an array that does not exist, but if you want to handle it, okay, if you access a particular index that doesn't exist, I want to handle that case, then you want to use the get method. I hope that's clear. Then we have the array macro. Now the array macro is like when you want to define an array, but you want to pass in like values into the array. You don't want to use the append keyword. Like you know the value that the array will take. So why not go through the struggle of having to define the array like this and then do append. You get. With the macro, you basically just do So as against us doing all of this, yeah, having to do iterate it and then do append, you get. all of this line of code, right? You can basically do this array 3, the arrow macro, passing the values in the array. And this is useful in the case whereby you know what the array values will look like. Just use array macro and you pass in the values into the array straight up. But if you don't know, maybe somebody is passing the value for you, is calling the function and they're passing those array values into them, then you want to use the append. So every time the person calls the function and passing the array, the value of those array, you use index to append them. But if you know the values, straight up use array macro and you append those values into. So that's like what we can use with array. Then represent snapshot of an array. Again, then span, right? So span basically represents a snapshot of an array. Now, it's designed to provide safe and controlled access to the element of an array without modifying the original array. Now, if you want to, if you know that you're not going to change the array, we want to get access to them, then you can use the snap keyword on the array, right? And then you get access to them. And then from there, you can get access to whatever value you want to get from there. Yeah. So if you want to get access to, in a sort of like a control safe way, you use the snap. And then you can get access to that. You know that you're not changing the array values. You want to get access to them, you can use the snap and get access to that part. So yeah, that's like array in a nutshell, right? I don't know if anybody has any question that we want to go over before we move to the third part of the class.
Basically, the at and get keyword
Yeah.
is close to target like an array, like using the index, right?
So if you want to get a particular value of at a particular index, you use either the get or the at. So you have your arrays, you pass some value into them. You want to get a value at a particular position. You either use the get or the at, but depending on your specific use case, right? If you want to handle the error, if you're using get, know that you need to handle the value return because it's going to return you an option. So you need to use match to handle the result, the sum value, or the non-value. But when you use get, it returns you the actual value, but it will panic if there's no value at that index they're trying to access. So, and what that means is that your program will crash if it panics because you're trying to access an index that doesn't exist. You get. So, okay. Change position as like. You want the value at index 4 to go to index 2. So that's what we call the updating of arrays, right? And with the way Cairo is, it's not actually like possible to do that way. You have to think of a different data type that you want to do. And that's where we now talk about what dictionaries. Because with dictionaries, you can actually like swap for positions because they are like a key value pair. When we get to that, you see, but essentially you would with arrays you can't update a particular positions. You either append at the end of the array or you pop at the beginning of the array. You can't remove at a particular position. That's basically like updating. So when you're writing your program and you have a use case of using array, once you know that you want to change the array at a particular index, it's not, because of the way Cairo is written, you can't do that. You have to think of a different data type which is why we have what dictionaries. So yeah, let's talk about dictionaries. Yeah? Any other question in Iris? We don't. Okay. So let's talk about dictionaries, right? Now, when you're coming from another language, let's say JS or Python, we have what we call dictionaries in Python, right? Which are like a key value pair of object, key value pairs, right? A type that has key value pairs, right? But with dictionaries, they are also like a dictionary like type that has what a key and a value. Now, you might be wondering, right? If you're saying that Cairo is memories in Cairo are immutable, right? So why are we having dictionaries that had key and value pairs, right? Because what that means is that if I know the key in a particular position, I can actually go and change it, right? Which is like the same thing with array, right? Because I know the key. The only difference is that in arrays, you're not defining the key. But with dictionaries, you're defining the key. And the key is always a felt 252 value. Now let's go over the text so we'll see what I'm trying to say. Now, Cairo provides in its core library a dictionary-like type called felt 252 dix of type T. It represents a collection of key value pairs where each key is unique and associated with the corresponding value, right? Cairo dictionaries allow programmers to easily stimulate existence of a mutable memory where there is none. Exactly. And because in Cairo you can't change memories, right? But with dictionaries you can actually like simulate. It's actually simulation because when we look at it from behind the scene, you see that it's actually like a simulation. You're not like changing the previous value. Now, the key is restricted to file 252, leaving only the possibility of specifying the value type, which is represented by T, a generic type. Right? Now, basic operations. You can do insert, right, using the insert keyword, and then you pass in the value and the type, and like the key and the value. And obviously, the key has to be of type felt 252, but the value can be any type, which is why they added like a T here, signifying it with a generic type, right? And then the gets. If we know the type, if you know the key, right, we can actually get the value there. And the value is a generic type, right? Now, then we have this example. I'm going to go through, we can look at it from code to see how it actually looks like in code. CD, yeah, scab, new, dix, smart object, yeah. Yeah. Now, let's okay, folder smart object. Okay. Okay. And this also. Okay. Let's clean up everything that we have. So we want to write a program that shows us how to access, how to insert a value in the dictionary, how to get the value in the dictionary, how to also update the value in the dictionary, right? First I'll start with our main, right? and our main does not return anything, right? Now with fields, with dictionaries, you have to import the definition, right? And in this case, we are saying that we want to have what balances, right? And it's going to be we are saying that it's going to accept FL252 of U64. Well, let's say 128, right? Because somebody's balance can be as high as possible, yeah? And yeah, this is now we have balances, right? Now this is how you define your dictionaries. We import the definition, you specify the type. What this means is that no, not the type. You specify the value that dictionary will accept, because by default the key is FL252. So you don't need to specify it. You specify the value, type of the value that is going to accept, and then you define the default type, right? Now, if we want to add, let's say we want to add our balances, we can say balances dot insert, yeah? Let's do the Bob. Yep. And Bob has 330. No, I don't think this is it. Let's look at it clearly. Okay. So yeah. Remember file 250 is a string. So we have to define it this way. And also, yeah, the mute, right? So we are mutating something. You have to find with the mute keyword, right? If you didn't put the mute, it's going to shout that, look, yeah, I know you define an empty struct, right? But you don't tell me to mutate it, so I will not. You have to define it with the mute. Yep. Balance. Let's say insert. I'm always like to do this. Yeah. Let's say Bob has 20 stack. Yeah. And let's say balance dot let's see we'll have what. Let's bring his second half. Yeah. Let's say he has 10. Yeah. Now this is inside operation, right? Now for us to get, we use this. Yeah. Let's do this. Yeah, let's see, get Alex balance, right? Yeah? And then we do balance dot get. What do you want to pass? You want to get balance of Alex, right? Okay, yeah. Then we'll do like an insert, right? To see what is returned for us, right? Now let's Cap, Cairo. Yeah? Yeah. Putting a trade. I'm wondering why something wrong with my auto formatting. Just try to get something that does not exist. Yeah. Can you see? So let's actually like remove this assertion and basically say print. Yeah, so that's why it's the assertion is to check a none, right? So it's going to throw this error because it's checking that the balance is 100, but the balance is what? 20. So this assertion will fail and it throw this error. So when you do print, hope I'm not that fast here, because I believe that this part is something that like it's critical to every other language, right? Because there's just a key difference which I probably need to draw on the board there to explain to you guys how this mutation things happen. Now let's run this. 25, okay. Yep. Alex balance is what, 20. So there's no all of those things around match, unwrap. You know where you put in there. Once you pass in the key, you get where you put in there. Now, the very interesting part here is how it's able to mutate the array. Have a question? Now, we create, this is just explaining what we just did here. So there's no. Hope you're following. Yeah? Hope you're following. So let's see. Okay. I didn't get that. Okay, let's see. So it's panic. A panicked here that the balance is not 100. Okay. Yes. Yeah, so that's why. So it's not like adding up. Exactly. So that's why if you're writing your own program and you're doing this kind of logic and you want to update somebody's supposedly like balance, you get his previous balance, right? Add with the new balance and then you. So that's how, because of the way Cairo language is, right? You have to especially you don't assume, you have to do it. Not like other languages whereby they can just update for you. But with Cairo or with Rust in general, you have to do almost everything yourself. So get the value, but I'm wondering why it's not getting me the balance. I'm wondering why it's not getting me the balance, because I set the balance of this at 100. You know what? Let's see. Let's remove this insert. Hmm? Mute? Where? It's, it doesn't need to mute. We don't need to need to mute. It's basically redeclaring the same name. It's dropping this one and redeclaring it again. So let's see what this is saying. Yeah, shadowing you need to remove. If you're shadowing, you need to remove this. Oops, sorry. If you're shadowing, you need to remove this. Yeah. Yeah, so you need to do, if you're shadowing, you have to put a mute and then you shadow it this way. Can you see? First balance is 20. Second balance after update is what? Huh? So the same way you insert, just call that index value, which is in this case Alex, and you pass in a new value. Now, I need to find a way to, so that text is not here. Yeah, so this is what happened behind the scene in the dictionary. For the very first time that you define a dictionary, right, it has three values. It has the key, the previous value, and the new value. So when you define an insert, when you define this insert, it has something called entry. How do I this? It has something called entry, which has key, previous value, and new value. Now, every time you do an insert, this entry is created in memory. For the very first time that you define your dictionary, they are all zeros. When you do the first insert, it creates the key, which is Alex. The previous value will be 0, and the new value will be 20. When you do another insert again, it creates a new memory slot again, picks the new value. The key is Alex, right? It keeps the key as Alex. The new value of that previous entry will be 20. The new value of that previous entry will not be our previous value in the new entry. Then the new value you're inserting will not be the new value for the new entry. Let me get, let's look at it, how this work. Now, see it as like the entry, right? Having something like, right, where it has like the key, right? The previous value, right? And then the new value. Now, when you create your dictionary, right, what you have is, let's say these are memory slots. What you have is like basically the key, previous value, right, and the new value. Now, for the very first insert, what happened for the very first insert is, you have what? Alex, right? That's the key, right? The previous value is going to be 0. Our new value is going to be what? 20. For that very first insert, right? The second insert we still carries what? We still carries what? Alex, right? Now, our previous value was 20. Our new value will be what? 100. Now, if you're doing insert for, let's say, you're adding value for, let's say, door. Or let's say John, maybe, yeah. CB0, 30, right? Now, all of these are memory slots. So you see, we're not changing the memory. We're creating a new memory slot. And if you're going with this way, the dictionary operation is a bit expensive because every time you're adding value, you're creating memory slots, right? You're doing, and it has to go through. If you have a long memory table, right, and you added a lot of value for Alex, Joe, and all of that, now you want to update it, it has to go and look, what is the previous value of Alex? Right, and previous value of Alex, what's the new value of Alex? Which is 100. And then if you add, if Alex now come and say, okay, my Alex new value is 120, right? Your previous value will be what? Right, and then the new value will be what? 120. That's how it is. That's how it keeps going. So it goes through all of it for a new Alex and the other. So if you notice that we are not like going to say, remove this and say, it's 100. No. That other one is still there. We're catching a new memory slot. So when you do your get operation, it doesn't pick this one, it picks the last one. So it goes through all of it and get the last one.
Also, can you get the previous value like from your program?
Now, the Cairo program, I'm not exactly sure if there's an inbuilt function to get the previous value. But what you want to do is, if you want to get the previous value, before you do the insert, do a get operation to get the previous value. If you want to add it up or you want to do whatever you want to do with it, then you do whatever you want to do with it. Then you do a new insert. So that's like one cron. If you want, before you do the insert, you want to know what's the previous value. You always do your get operations to get the previous value, and then comes back, do whatever you want to do with it, and then you do your insert. So this dictionary is a bit expensive operation, right? So you want to like think through, do I really need to use dictionary in this particular use case I want to do? If I need, then I straight up and use it. But if I don't need, then there's no point to do it. So behind the scene, this is what happened. This is what happened behind the scene. Keep adding up inside, adding inside, adding inside. If you want to get error. If you want to add, then you do add, and you get what you get. So the moment you do a new insert, you don't have access to the previous one. So if you want to know the previous one before you do a new insert, you do your get the previous one, do whatever you want to do with it, then you do your new insert. So this is how, like, on the behind the scene in the language, this is how they structure it to have it this way. So you're not changing memory slots. You're basically creating a new memory slot every time you do a new insert. But the language keeps track of the previous value with the key attached to it based on the entry. The key, the previous value, and the new value. So yeah, this is like what happened behind the scene for like dictionaries that makes you see that you're actually changing the memory slot, but you're not changing the memory slot. You're basically creating a new slot every time you do an insert. Hope that's clear. Yeah.
So is dictionary meant for all? Is dictionary purely for arrays?
It's not for arrays. It's just for where you know the key and the value. Where you want to store a key value pair kind of store.
Yeah. Like an array.
Not like an array. In an array, you don't know the key. The keys are indexed apart from 0, and you don't have control over them. But with dictionaries, they allow you to define the key as a file 252 value. But the value that key accepts can be either be of any type. That's why you see they have the generic of type T. I don't know if that makes sense. Any other question on dictionaries?
So dictionary is meant for updating.
So depends on how you want to use dictionaries, right? Or in your use case, right? If you want to store values that have key value pair, for example, the balances here. Let's say you want to keep track of everybody's record and where they are in their progress of certain actions that they're doing or certain work that they're doing, right? And you have like a point, like a grading point system. That's okay. If you got into this stage, I will give you this point. I know your name is your key. I'll give you this point. If you go to the next step, I'm going to give you this point. You want to use dictionary. Because you know the key, which in this case is the person's name, and you also know the value you want to insert. And you want to always get the last value of that key, right? So you want to use dictionaries.
So it's like a mapping in solidity.
Huh?
So it's like a mapping in solidity.
Kind of like a mapping solidity. So yeah. I hope sort of like, okay.
Like this dictionary, does
Yeah.
it work like objects or
They work with like object exactly. But the only difference is that the key has to be FL 252. 252. Yeah. You can't use a different type for the key. The key has to be FL 252. But the value it accepts can be either FL 252, a string, a signed integer, and unsigned integer. You're allowed to have that. And why they use that key is because they want to keep. It's because of the entry, the way the language is designed. They want to control over this, over the key. But you have option to do how you define the type that this previous value and new value takes. So yeah, that's that for that. Okay. Are we clear on dictionaries? Okay. So okay. So the next part, right, which is sort of like which to some extent we sort of like cover it, but it's important that we sort of like look at it on a on like a specific use case handle, which is the error handling part, right? Now, in every programming language, right, you have to catch errors, right? You have to catch errors. Either from somebody passing in some data, you want to make sure that, okay, I said I need to receive string, and you're passing me file 252, or you're passing me U25, I need to catch that error, right? So it's very important that we go through this. And in Cairo, there's two types of errors. Unrecoverable errors with panic, and then recoverable errors with results enum. So you can see we are back to results enum, option enum, and all of that. So it's important that we sort of like understand how result enum works, right? Because you need to use them in even when you're trying to catch errors and all of that. Now let's look at what the text is here is saying. Panic function from core library does not provide resolution for this error. There are two primary ways that a panic can be triggered in Cairo. Through actions caused by the code, panic, right? For example here, you're accessing an array beyond its bound, right? You have an array that has 3 values. and then you came and you want to access the value at position 5 or at position 15. You're already getting access to, you're trying to access value that is out of bound, right? So it's going to throw an error for you. Then secondly is you deliberately invoking a panic function in your code, right? Let's say, for example, you want your function to only accept certain number of values. And if somebody passes more than that value, you want to do something. Maybe you want to say, okay, fail, let the program fail automatically. You can invoke a panic function, and that once the person passes that value that is not a range where you expect, it's going to panic, and the program will crash. That's like 2 ways to do this. Now, so the panic function takes an array as an argument, which can be used to provide an error message or perform an unwinding process where all the variables are dropped and dictionaries are squeezed. Yeah, there's a part in the dictionary that I didn't discuss, which is the dictionary squeeze, which is in the Cairo book. So you want to like go over that particular part and read through that particular part. Essentially what it means is that once a program finishes executing, that dictionary, that memory will be sort of like squashed down, dropped. Yeah. So with panic, when you execute the panic operation, all the variables get dropped, all dictionaries are dropped, the memories, everything in the memory is dropped completely. Now, you can see here, right? We have this function. Let me run through a new Cairo program. Oops. Yep. Okay. Scab new. Oops. Yeah. Oops. Oh, okay. I actually went and created the wrong. Cairo tests. Yeah. Yeah? Okay. So let's bring it up here. Oops. We want to clean up everything, right? Now, if you notice that, I know all of you guys have written Cairo programs before, right? And you notice that what we have here is panic as a function, not panic as a macro, right? Let's mute R equals to, yeah, let's use, yeah, let's use 10, yeah? And let's say we are trying to get access to, yeah, we just want to panic, right? If true. Yeah, if true, panic with the data. Oops. Yeah. Yeah? If else issue what do you think will happen in this code here? What do you think will happen in this code here? We are defining an array, right? And then we are saying if true, panic with the array value, and then after that print this. Where do you think the program will stop with execute? So this is a case whereby you are deliberately invoking a panic function, and your program will stop here. It will not recover from here. Once it gets here, it will panic, and everything will get dropped. It will never get here, because you are deliberately invoking the panic function here. So now let's run through the scab Cairo -run, right? Thank you. Let's see what happened. Yep. Run panic with these values. Can you see? So this is using the panic function to sort of like throw an error that is unrecoverable with the panic function, right? Now, then using the panic macro. The panic macro allows sort of like input like file252 string of error message. So it doesn't accept arrays, it accepts a string of message that says, okay, this thing failed because this is what happened, right? And let's ultimately try this out and see. So all of these are errors that are unrecoverable. Once it throws that error, your program crash. Yeah? Well, in this case, it sends us back the error message that's okay, your program crashed because of this. Yep. Can you see? Intentional call for panic. Yeah? And it crashed. It never goes here. Yeah? It's all recoverable, right? So that's like the arrow macros, right? Now, what are the use cases where we want to use them? During development or testing, right? If you are trying to test, maybe you're writing a program and then you are expecting a behavior that you don't expect. You could drop some panic within the code to see, are we getting here, what's happening here, what value is getting here. You print that value or you panic at that point, right? And then for some security critical conditions, right? When continuously execution could compromise security or potential lead to list of funds, you want to throw a panic, right? Let's say there's a particular behavior that you never expect your program to do. You want to catch that particular behavior. And whenever that behavior happens, just panic and crash the program. You want to use panic that is unrecoverable in that case. Then input validation, right? Let's say you are expecting a string and somebody went and copied one SQL query injection, one long SQL query injection, and threw it into you. Obviously, you want to panic at that point because you don't want that particular string to get past that your input validation. So you want to use panic for input validation. Automatically crash. Once I'm not getting the right values in my input, crash the program. Because you don't want to pass in an incorrect input to the other side of your program, which might immediately do something that you don't know, right? Internal logic error. Now, when you detect a condition that should be impossible, according to your program logic, indicating a bug in your code, you want to write a panic, right? For example, you have a division operation that you never want to have a division to result into 0. And when it results into 0, you want to just crash the program. You can use panic that is irrecoverable. Throw a panic message that's okay, this thing will fail. Should never happen. Yeah? So these are like use cases of where you want to use panic that is irrecoverable. That is what? Unrecoverable errors. Now, so these are like, panic is basically used when you want to throw an error that you know you will never recover from the error. Your program will crash. You want to use panic for that. Then the second error handling is with results enum, right? Not all errors in your program, right? Sometimes when program fail, there's a reason for that you can easily interpret and respond to. Exactly. So you want to use error. You want to use result enum, right? Either you return me a result success of T or an error. And when you return me an error, I want to catch it. So I use match operation to catch the success value, the OK value, or the error. Right? Just as we saw in the example of using the match keyword with success and error. Okay, there's no example on this. Okay. So result enum, I mean, as you already know, right? It has what? T and E, right? And two variants, right? OK holds value of type T and error holds value of type E. The definition makes it convenient to use result anywhere there's operation that might succeed or fail, right? So let's see if you can sort of like write a function that returns a result enum. Let's see of U128, it returns U result T. If I multiply by 2 equals to, oops. Multiply by 2 equals to 100, you want to result, right? I multiply by 2, right? Yeah, so we're supposed to use match, right? Yeah? Okay. Let's see what this is saying. I think we're supposed to use, yeah, so we're not, we're not supposed to use match because we're returning 0, yeah? Else results, oops. Oops. So, yeah, so here we want to say return a U128, right? And also, yeah, we define that return a fell 252, but we have to fix this, right? Yeah. So why are we having this? Yeah. Yeah. We are assigning instead of comparing. Now, in our program, we can say yeah, even from here. So, yeah, right? So, we want to use match, right? To say our smart results, if results okay, yeah? If result okay is of value of t, yeah. You want to print, right? Say, yeah. Okay. Then what? T, right? When you want to see results, okay, of T, let's say A. We want to see, why is this one shouting that we did not did this? Yeah? So let's execute our program and see what happens. But obviously we need to comment out all this, right? This line, right? So you can see that we are actually handling a recoverable error that we can actually handle, right? Let's see what happened. So let's say I pass in $100, yeah? Can you see? We catch the error, right? And then the program actually completed. So it did not panic, it's completed, but we didn't catch an error, because that's all what the program is expecting. So yeah, that's sort of like essentially like handling errors, right? You use the result enum to handle errors if you know that the error is recoverable, right?
Yeah.
But if you know that the error won't be recovered, you want to throw panic, and then that's how that's being handled automatically.
I want to use options for recoverable error.
I don't think so. You can't use option because there's not error variant in the option. It only returns you a none, which means there's nothing there. But if you want to handle error, you use the result enum. Return you a success and an error. So you catch the success and you catch the error. But if you know that the function returns you a non-value, then you use option enum. Catch the sum value. If some value is not there, you catch the none. So that means the function does not return an error. It returns you a none if nothing happens there. So yeah, this is like, this is sort of like everything about error handling, sort of like Cairo. So does anybody have any question? Yeah? Yeah. Yeah, so like I said, right? For instance, you have a program that sort of accepts a certain value and that does something for you. And somebody came and passed in some crazy SQL injection scripts. You know that you are expecting to receive a value of L250, which is size of 21 bit, right? And somebody came and passing one long. You get, so in your program, if you want to validate the inputs, right, and you want to take care of that kind of scenario, you basically just panic at that point because you don't want it to go past that stage. Automatically panic. The program basically crash for that person trying to call that program. That's like a typical use case for that case. So anything that will sort of like serve as a security vulnerability to your code, once you get to that level, you want to panic and crash the program. So it only stopped at there. It doesn't go beyond that to execute anything. Yeah, any other question? Do you have any other question? We don't. Okay. So okay. So we're supposed to do one last thing. Let me ask some question. Okay. So we're supposed to do one last thing, which is sort of like based on what we've learned, right? Try to sort of like build a task or sort of like a to-do kind of program, right? And I'm going to sort of like walk us through that. And the idea is after this, you can sort of like improve the program based on where you sort of like learned from these sessions. Yeah? So let's start afresh. Create a new program. Okay. Okay. Scab new. Yep. Cairo program. Yeah. So let's do tax, right? Oh, okay, sorry. We have this, right? So we want to clean up everything and clean up everything. So we have a what we call like we have what we call like clean, right? And then we start from there. What do you want to have first? We want to have our entry point, right? Now, what we are trying to do is a tax manager, right? Where we can add tax, right? Update tax. Update tax priority level, right? And also be able to get tax. Get tax. And also sort of like delete tax, yeah? Now, we are going to use, we are going to do this with FEL 252, sorry, a capstone dictionary, right? So we want to do core dix. FEL 252 dix, yeah? Now, FN add tax. You want to start with the first add tax, right? And what does he want to do? He wants to sort of like collect the name, which is FL 252 value and priority, which is a U8. Yeah. And also is going to reference the sort of like it's going to reference the tax manager, which in this case is going to be a felt yeah, it's going to be a felt 252 that basically accept a U8 value. Yeah. Now, what do you want to do here? You want to add, right? So we want to do tax manager dot insert, right? And then what happened? The name, right? And then the priority level, right? We want to print tax what added, right? And the name, right? Hope you are like following what we have here, right? Now the next function is going to do what? Update, right? FN update tax, right? We're going to have the name, right? And it's going to do what? New priority. Yeah. which is a U8, right? And it's going to reference the what? Tax manager, which is also a felt 252 that sort of like accept what's a U8, right? And what this, okay, I'm missing the part here, type here, right? This is FL 252, right? Now, update, and we said in dictionaries when we are updating, we're basically inserting, right? New entry, previous value, new value, and the key, right? And in case where the key doesn't exist, you basically do an entry, right? A new entry. So we want to do tax manager dot insert, yeah? The name and the new priority, right? Tax updated, right? And the name of the tax, right? Now, you want to do a get, right? And the gets basically do what? It's almost the same thing with this, but let's see. Let's see, FN, right? Get tax priority, right? So, yep. And what does it do? Accept the name, right? FL252, right? And reference the, what? The tax manager, right? And in this case, we want to okay. We want to do tax manager dot get name, right? Because we always pass in FL252 name, right? And we want to do what's print, yeah. As a priority, what? Level of what? Yeah. So name, yeah. Priority, yeah. Are we good here? Now, the next thing we want to have is delete, right? And in delete, yeah, that's another very interesting scenario. In delete, we are not moving memory, right? We're basically setting it to 0. Yeah. So we're not doing anything. We're basically setting it back to 0. Because, like we said, right, you can't mutate memory slot in Cairo. So if you want to delete something, default it back to 0. Delete tax, right? Get the name, FL252, right? Reference the tax and do this, right? Okay, so we'll do a tax manager dot insert, right? Name 0. What do we do? What do we do? Tax deleted, right? And the tax name, right? Now we'll come back to our main program. Just a second. Come back here. I'm going to paste something here and sort of like edit them. I want to say it's tax manager and it's a what? 8, right? And yeah, so get to. Oh, okay, we did a mistake here. Update tax, right? And also, yeah. Then we can say add tax glossary of 2. And then we now add it up and say glossary of 10. And then I'm going to come back and say get tax priority and the name, right? And what's the name I want to get? I'm going to say tax manager, right? Okay, why is it shouting? Did we do anything? Oh, yeah. Yeah? So yeah, so we're almost rounded up, right? So we'll add one particular tax to delete, and then we'll try to read and see the value there. Let's say we can't delete comma. It's not possible. It's not possible. It's not possible. What should we? We can delete finished project. Yeah, I agree. Delete tax, so the name, right? And we want to see how we can get that same tax. Yeah? Okay. So we'll see what happened. We deleted it and then we're trying to get the value from there. I want to see what happened. Yeah? Scab Cairo -run, right? Let's see what happened. See? Tax with name. This has a priority level of 0, right? Because we deleted it. Okay, see, it has the same hash. And now it has what? 0. So this is basically it, right? And the idea is, and that you sort of like understand how to work with advanced data types, right? When you get into stagnant smart contract, you use what you sort of like understand from here to ease yourself into that particular field. So yeah, I don't know if anybody has any question, so we can go over them. Yeah? Does anybody has any question? Okay. Yeah, so I'm going to lump up all of this and add it to the Cairo repo. I'll do it today. If I'm not able to do it today, hopefully by tomorrow I should be able to push that up. Yeah. Any other question? Yeah? So in the absence of any question, right, I will call this a day, right?